This problem gives you some different ratios and asks you to determine the reference angle that we must have to make those ratios happen in a right triangle. So first we have opposite over hypotenuse, so we know that we should be using arc sine, sine inverse. So you'll just type in sine inverse of 9 divided by 17 and see what you get. We get about 31.97 degrees. So that is the reference angle needed to make this ratio in a right triangle. For adjacent over hypotenuse 2 over 11, we're going to do arc cosine of 2 divided by 11. Now, first thing, before we hit enter, we see the adjacent side is very small compared to the hypotenuse, which means our answer should be like more on the 90-degree side than on the 0 side. A small adjacent side with a big hypotenuse makes a big reference angle. So let's see what we get. Yeah, 79.5 degrees. Okay, that's a pretty large angle because of this ratio, 79.5. Okay, opposite over adjacent is 9 over 12. Okay, so in this case, our opposite and our adjacent are actually closer together, with the adjacent side being a little bit longer. So we know that this angle should be less than 45 degrees. Because if these were the same, if they were both 12, then that would be a perfect 45-degree reference angle. If the opposite side's bigger, that makes the angle bigger than 45 degrees. And if the opposite side's smaller, that makes an angle smaller than 45. So let's see what we get. Arctan of 9 divided by 12 gives us 36.87. So not too far away from 45 degrees and less than 45 degrees as we predicted. All right. Last one says just hypotenuse over opposite equals 4. So I went ahead and added the 1 here because we're saying the ratio of hypotenuse to opposite is 4 to 1, which is the same as 4. So there's no arc cosecant button on your calculator, but we can just go ahead and flip our ratio and say opposite over hypotenuse equals 1 over 4. And now we can just use arc sine, and we get an angle of 14.48 degrees. And that's it.